All right, we're going to be talking about the matched pairs t-test today. This is chapter 25. I'm actually looking at number 19 in the book if you wanted to kind of look along or try this ahead of time and then come back and watch it after the fact and see how well you did. Number one, this is about a company who decided to institute an exercise break and see if that would improve workers' job satisfaction after they created this new benefit that would allow people to work out on their break. So we have 10 people, and we're going to be asked questions, right? So you have all 10, and then we're going to say, well, how satisfied are you with your job before this all starts? And they all gave a score. And then afterwards, they all gave another score of how satisfied they were in terms of what did they feel about their job after they instituted this new workout session. And so what we're going to do is we're just going to do phantom and kind of run through this and talk about the results, right? And so the P that we don't, obviously is not graded, but the question is really, does the job satisfaction, does the exercise program improve job satisfaction, right? So job satisfaction. Next, H. We need to write out our null alternatives. Now, this is a big deal. You don't do null alternatives like you've done in the past with the 1 and the 2 sample stuff. When we look at our hypotheses, we're going to really define a few things, right? We're going to say that mu after minus mu before. Whenever I decide that this is a matched pairs test, I'm going to have to decide how to subtract them. Mu A minus mu B is equal to mu D, right? And by mu D, what I mean by is the difference. And that's really important. A lot of people tend to try to do this with a 2-sample test where you say mu A is equal to mu B, and that's technically incorrect. And so make sure we do it this way. The null for a matched pairs test is going to be mu D is equal to something. In this case, we're assuming that their before and after scores are the same, that the exercise equipment didn't help, right? We always assume that everything stays the same for the null hypothesis. So if I subtract the 2 scores, then I should find out that there's no difference in the 2 groups. That would mean that their after score was exactly the same as the before score, meaning that nothing affected them. The alternative is that they feel that the exercise program is going to improve their scores, right? So if this number is larger, meaning a higher after score, when I subtract a larger number minus a smaller number, I should get a positive number. I should get something that's bigger than 0. And so that's kind of how we build our null and alternative. And it's always going to be mu D equals 0. And then the alternative, this really is sensitive to how I subtracted this. If I had done before minus after and reversed the 2, then I would have gotten a less than probably here, because the smaller number would have gone first. Like 3 minus 5 is negative 2, or 5 minus 3 is positive 2, right? Whatever number is first is really going to, where your big number falls, that's going to play a role in choosing your alternative hypothesis. Okay, it was important that we made this difference. In fact, I'm going to be looking for this kind of thing. Now, I don't have to use after and before. I could use some other naming scheme that makes more sense in a different context. But this one, after and before, is what they used here. So it helps me to kind of figure out how to label my hypotheses. All right. My assumptions. Now, this isn't a whole lot different than a 1-sample test. We have randomness. In this case, yeah, it is random. Sorry, it's stated in the problem. It's stated randomness. We have independence. Now, this is the person's opinion about their job is independent of another person, right? So people's opinions are independent. Right? And then we have 10%. This one's kind of a bit of a stretch. A lot of us, we're not really sure how big the company is, but if we just take a traditional sized company, if we multiply by 10, we would think that 100 is definitely less than 10% of the company's population. That would mean the company would have 1,000 different people. The company has to have at least 100 people in their business, which in most standard businesses, that's definitely possible. Okay, and the last one is nearly normal. Now, I realize that in this digital context, unless you're submitting a picture like you're going to be doing today, then this one is just simply like when I gave it to you on the Google form. You just pretty much had to go with it and tell me what you saw. I couldn't really check that, but do give a good accurate description unless you're going to be drawing it. Just before we go into the graph, I want to kind of explain what I did in my calculator. So for me, I wrote down L1 here. This was L2, and then in L3, I made sure to say L2 minus L1, and it gave me the 10 differences right here. So here you can see the list that I got out of my calculator. And I did all this I didn't really do the subtraction. I entered before, I entered the after, and then I let the calculator do the differences. Now let's look at the graph, and to kind of set that up, I'm in second y equals, and then we're using plot 1. We're using the 6th icon, which is the normal probability plot. So I'm going to sketch that real quick. And here's my graph, and I try to draw it as accurately as possible without getting too detailed with it. And remember, what we want to look at is this a straight line, right? It looks pretty straight to me. It's not curved at all. So you can say the graph is linear. So data are normal. As long as this graph is straight, then you know it passes the nearly normal condition. Okay, so let's keep on going. So next we have, and this was probably one of the most missed things on the little quiz I gave, PHAN. I need you to name the test. A lot of you did a 2-sample test for a problem like this, and that's an automatic 5 points off, right? It doesn't even matter if you got the rest of it right or not. And so this is a matched t-test. We're going to be using the t-test in the calculator, but it's a matched test because we had to subtract 2 lists to get the new list. And that's why we call it matched. So PHANT, the test is, a lot of you missed this one too. I'm going to get the t-score, and then I'm going to get the p-value, and then we'll write our conclusion out. Inside my t-test, I want to kind of go over that. Here's what I'm using now. I'm in the calculator. I'm under just plain t-test, not 2-sample, because this is not independent groups. Right, now you can approach this in a couple of ways. Independent groups means that, are the 2 groups that I have independent of each other? And the answer is no. You'd say data are paired, right? So this fails. Data are paired. Okay, and so that 1, 2, 3, 4. Yeah, that's 5 different assumptions for that. So let's back to the t-test. T-test, I'm going to be using data because I have a list. If I had given you averages and standard deviations, then I would be using stats. Right? So data, my mu0. Well, what did I put in the null hypothesis? Well, we said it was equal to 0. And then we're using a list here, so this is going to be my L3 list because that's what I use for my differences. And the frequency list, leave it as 1. Don't just leave that alone. Don't ever mess with that. And then the alternative here is mu is, we're going to say, I think we're saying it's greater than 0. So what I want to do here is just make sure that I use a greater than symbol there, which is going to be the third one, right? The third choice. And of course, I'm just going to calculate it at this point. I'm going to write down all the values that come out of that, what we want to know. Here's the t-score. T equals 3.5973 if you round it to 4 places. And our p-value turns out to be 0.0029 to 4 places. We're still going to use an alpha level of 0.05. And so now it's just left for us to write a conclusion. And so we'll put that over here. Conclusion. Remember, it's phantom. I was really surprised, a little disappointed that the number of people that didn't do phantom. And I know I didn't write all of those things down. But whenever you do phantom, make sure you include the necessary elements. So let's finish this up. Let's start off with the basics, right? We want to make a decision. So I reject the null. And we'd say because my p-value is less than alpha. Now that's okay, that's 2 of the 3 parts, but I'm still missing the context. Like, okay, so what does this all mean? Right, our evidence suggests, there's no S on that. CE, our evidence suggests that the program worked, that the program improved job satisfaction. And that completes the whole picture, right? That way we would be able to say that the program that they created worked, it improved job satisfaction, and went from there. Next, just to kind of an addition, we're going to kind of, well, let's answer part C. If your conclusion turns out to be incorrect, what type of error did you commit, right? What would this? Well, we had rejected the null, right? When you reject the null, if you're wrong, that's a type 1 error. Remember, if you fail to reject, that's a type 2 error. But what I wanted to do originally was I want to do a confidence interval. Now, I don't have to go ahead and check anything, but we're going to use a matched t interval. And then we're going to do that interval and write it down here. Here our interval. Now I used a t interval. I used data. I used the L3 list, and I used 95% confidence. And so we ended up getting 3.1547 to 13.845. The important thing here is that we have all positive intervals. So that means 0 is not in the interval. So when I write this out, I want to make sure that I talk about the average difference in the before and after score was between these numbers. And you read it something like this. I'm 95% confident that the average after score was 3.15 to 13.8 points higher than the before score. I use the word average in the question, so I don't need to state it on average at the end, but I could also have put it there rather than putting it before. Okay? So this is how you would complete phantom and panic for this, right? So this part of panic, we named it, we gave it the interval, and we wrote our conclusion out at the end. So just to kind of finish up the parts that I hadn't already done on the previous one. Like we'd already written out the assumptions and conditions, so I didn't need to redo that. And this completes the whole package, right? You've got phantom, you've got panic, you've got writing conclusions, you've got setting up your hypotheses. These are things that you just can't not understand. Like this is a huge component of all this stuff. Make an effort to try this on your own, or try the example I attached on your own. And if you have questions, please get in touch with me.